Light is leaving the face of someone you trust right now, bouncing off their skin in every direction at 186,000 miles per second, and a thin cone of it is entering your eye through an opening that looks like a simple black circle. It is not simple. That black circle is a muscle. Two muscles, actually, wrapped around a hole, and in the half second you spend looking at this person, those muscles are going to move without your permission, without your awareness, and without any command you could give them even if you tried. The black is not a color. It is the absence of returning light, the same reason the inside of a camera is painted black, the same reason a window looks dark from the street at noon. Almost every photon that crosses that threshold is absorbed inside and never comes back out. What you are looking into when you look into someone's pupil is the one place on the human body where you can see directly inside the nervous system. No surgery, no instrument, just the opening that lets the world into the brain. And the size of that opening is being set, in this moment, by a negotiation between two halves of your nervous system that are pulling in opposite directions. Here is the anatomy, because the rest does not make sense without it. The colored ring around the pupil is the iris, and the iris contains two separate muscles arranged in two separate geometries. The first is the sphincter pupillae, a ring of muscle fibers running in circles around the edge of the pupil, like the drawstring on a bag. When it contracts, the circle tightens and the pupil shrinks. The second is the dilator pupillae, a set of fibers arranged like the spokes of a wheel, running radially outward from the pupil toward the edge of the iris. When those spokes contract, they pull the opening wide, the way pulling on the spokes of a wheel from the rim would stretch the hub outward. Two muscles, opposite shapes, opposite jobs. One closes the aperture, one opens it, and they are not controlled by the same wiring. This is the part that matters. The sphincter, the one that constricts the pupil, is driven by the parasympathetic nervous system, the branch your body uses for rest, for calm, for digestion, the branch that runs when you are safe. The dilator, the one that opens the pupil, is driven by the sympathetic nervous system, the branch your body uses for arousal, for alertness, for the surge of readiness that older textbooks called fight or flight. So the diameter of your pupil at any instant is a readout of which branch is currently winning. A small pupil leans parasympathetic, calm, settled. A large pupil leans sympathetic, aroused, activated. The aperture is a dial, and the needle is pointed by your autonomic state. Now, most of the time, the thing moving that needle is light, and that is the reflex everyone knows. Photons strike the retina at the back of the eye. The signal travels along the optic nerve, and a portion of it branches off before it ever reaches the part of the brain that produces vision. That branch lands in the midbrain, in a structure called the protectal nucleus, and from there, a signal runs to a pair of cell clusters called the Edinger-Westphal nuclei, which send parasympathetic fibers back out to the sphincter muscle. Bright light, sphincter contracts, pupil shrinks to protect the retina and sharpen the image. Dim light, the parasympathetic drive relaxes, the dilator takes over, and the pupil opens to gather more photons. This loop is fast. It is automatic, and it is so reliable that it is one of the first things a doctor checks in an unconscious patient, shining a light in each eye to see whether the brainstem is still doing its job. A pupil that does not respond to light is a sign that something deep and serious has gone wrong. The light reflex is the baseline. It is the boring, dependable behavior of the aperture, and for centuries, people assumed that was the whole story. Light goes up, pupil goes down, light goes down, pupil goes up. A photometer made of flesh. But the aperture does something else, something that has nothing to do with how much light is in the room, and once you notice it, you cannot unsee it. Hold the light constant. Put a person in a room with steady, unchanging illumination, so the light reflex has nothing to respond to, and then have them solve a difficult multiplication problem in their head. Their pupils dilate, not because the light changed. The light did not change, but because the brain became aroused, and the sympathetic branch pushed the dilator muscle. Play them a sudden loud sound. The pupils jump wide. Show them an image that frightens them, or one that fascinates them, or the face of someone they love, and the pupil opens in identical light, driven by something that is not light at all. This is the discovery that turns the pupil from a photometer into a window. The aperture is not only measuring the brightness of the world outside, it is also reporting the state of the brain inside. And the brain does not distinguish neatly between kinds of arousal. The dilator muscle gets pulled by mental effort, by emotional intensity, by surprise, by fear, by desire, by interest. The same wide pupil can mean you are terrified or that you are captivated. The aperture tells you that arousal is high. It does not by itself tell you why. That ambiguity is going to matter enormously when we get to trust, because the body has to solve the problem of telling the difference, and it solves it in a way that nobody designed and everybody uses. So sit with what we have established before we go inside the brain. The pupil is a hole bounded by two muscles, one that closes it under the calm command of the parasympathetic system, and one that opens it under the aroused command of the sympathetic system. The aperture is therefore a continuous, honest, involuntary readout of which way your autonomic nervous system is leaning from moment to moment. Light moves it through a fast reflex you cannot override, and that same reflex lets the muscles also be moved by anything that shifts your level of arousal, attention, or emotion. You did not learn to do this. A newborn does it in the first hours of life. You will do it on the day you die. There is no muscle in the human body more honest than the dilated pupillae. Because there is no muscle, you have less ability to control. You can fake a smile by recruiting the muscles around your mouth. You can steady your voice. You can hold your hands still. You cannot tell your pupils what to do, because the wiring that controls them never connected to the part of you that makes decisions. And that single fact, that the aperture cannot lie, is the reason that what happens next, when you look at someone you trust, is one of the most quietly revealing things the human body does. To understand why the aperture opens for someone you trust, you have to follow the wire backward, from the muscle in the iris all the way up into a cluster of neurons in the brainstem, about the size of a grain of rice. The sympathetic command that pulls the dilator muscle does not begin in the iris. It begins much deeper, and the journey it takes is strange. A signal destined for your eye actually travels down out of your skull, down into your neck and the top of your chest, to a relay station called the superior cervical ganglion sitting near the top of your spine, and only then does it turn around and climb back up, riding along the outside of your carotid artery, threading through your skull, and arriving finally at the dilator muscle. It is a long, looping path for a signal that ends up only a few inches from where it started. And the reason it matters is that this long sympathetic wire is plugged into the body's central alarm and arousal system, which means your pupil is wired directly into the machinery that decides, faster than you can think, whether the world right now is safe or dangerous. At the top of that machinery sits a tiny blue-tinted knot of cells in the brainstem called the locus coeruleus, which in Latin means the blue spot. It is small, only about 50,000 neurons on each side in a human brain, but it is one of the most influential structures you own because it is the brain's primary source of a chemical called norepinephrine, the alertness molecule. The locus coeruleus is the volume knob for arousal. When it fires slowly, you are drowsy, calm, settled. When it fires faster, you become alert, vigilant, ready. And here's the connection that took neuroscientists decades to nail down with precision. The firing rate of the locus coeruleus tracks, almost beat for beat, with the diameter of the pupil. When researchers recorded directly from these neurons in animals while watching the pupil, the two moved together so tightly that the pupil became a way to read the locus coeruleus from outside the skull without opening it. The blue spot fires, norepinephrine floods outward through the brain, the sympathetic system lifts, and the dilator muscle pulls the aperture wide. Your pupil size is, in a real and measurable sense, a dashboard gauge for the activity of the brain's arousal core. When you see someone's pupils widen, you are watching their locus coeruleus turn up the volume. But arousal alone does not explain trust, because arousal is exactly the ambiguous signal we ran into at the end of the last part. Fear raises arousal. Threat raises arousal. The locus coeruleus fires hard when you are cornered and afraid, and your pupils blow wide open in terror, the same wide as in fascination. So, if the aperture only reported raw arousal, it would tell another person nothing useful about whether you mean them well. The resolution lives one layer deeper in a structure called the amygdala, the brain's threat detector, a pair of almond-shaped clusters that evaluate, before conscious awareness, whether something in your environment is dangerous. The amygdala has a direct line to the arousal and sympathetic systems. Detect a threat, and it slams the alarm, norepinephrine spikes, pupils flare, heart rate climbs, the body readies itself. This is the fear pathway, and it produces large pupils through a state of defensive arousal. Now here is the crucial thing about trust. When you are with someone your brain has classified as safe, the amygdala does the opposite. It quiets, the threat signal goes silent, and into that silence comes a different chemistry entirely. That chemistry centers on a molecule called oxytocin, a small peptide produced in the hypothalamus and released both into the bloodstream and directly within the brain. Oxytocin has a public reputation as the bonding hormone, the molecule of mothers and lovers, and that reputation is earned. But the mechanism underneath is more precise and more interesting. Oxytocin acts on the amygdala to dampen its threat response. In carefully controlled studies where people received oxytocin and were shown threatening faces, the amygdala's reaction measurably decreased. The brain becomes less defensive, less guarded, more willing to approach. So when you look at someone you genuinely trust, two things are happening at once that pull the aperture in a particular direction. The amygdala's fear-driven alarm is quiet, so the pupil is not being widened by defensive panic, and yet the person in front of you is deeply interesting to your brain, socially significant, worth attending to, and that significance, that engagement, lifts the locus coeruleus and the sympathetic system in a way that is not fear but its opposite, a kind of open, unguarded orienting toward another person. The pupil widens, but it widens out of safety and interest rather than out of threat. Same muscle, same direction of motion, completely different state behind it. This is why the brain cannot rely on pupil size alone, and it does not. Your perception of another person's dilated pupil is always read in context, against their facial expression, their posture, the situation, the history you share with them. A wide pupil on a snarling face reads as rage or fear. A wide pupil on a soft, open face in a calm moment reads as warmth and interest. The aperture supplies one channel of information, the level of arousal and engagement, and the rest of the face supplies the sign, positive or negative, that tells your brain how to interpret it. What makes the trust case special is that all the channels line up. The relaxed face, the quiet amygdala, the oxytocin softening the defensive circuitry, and underneath it the genuine, unfaked engagement of being with someone who matters to you, all of it pointing the same way. The pupil opens because, in the presence of safety, your brain stops shrinking back from the world and leans toward it. Constriction is the body's way of pulling in and protecting. Dilation, in the absence of threat, is the body's way of reaching out. There is a subtle timing detail that makes this even more revealing. The light reflex is blisteringly fast, a fraction of a second, because protecting the retina is urgent. The arousal-driven changes, the ones tied to the locus coeruleus and emotional engagement, ride on a slower current, swelling over the course of a second or two as the encounter unfolds and the brain processes who and what it is looking at. So when you met the eyes of someone you trust, there is the instantaneous constriction to the light of their face, and then, layered on top of it, a slower opening that follows the rise of recognition and felling. Researchers can separate these two components by holding light constant and measuring only the slow drift, and that slow drift is the emotional pupil, the part that has nothing to do with photons and everything to do with the state of the nervous system. It is sluggish precisely because it is not a reflex against danger. It is the body settling into a state of safe, attentive openness, and the aperture moving to match. So now the full circuit is in front of you. A face arrives as light. The amygdala checks it for threat, and finding someone trusted stays quiet. Oxytocin keeps that threat circuitry calm and the defensive walls down. The locus coeruleus, free of fear but lit by genuine interest, lifts its firing rate and pours norepinephrine through the arousal system. That arousal runs down the long looping sympathetic wire, out of the skull, down to the neck, back up along the carotid, into the dilator muscle of the iris. The spokes contract. The aperture opens. None of this passed through the part of you that chooses. You did not decide to find this person safe, and you did not decide to open your eye wider for them. A chain of structures you cannot consciously reach made the decision and moved the muscle, and the result surfaced on your face as a slightly larger black circle that you have no idea is even happening. Which raises the question that the next part has to answer. If you cannot see your own pupils, and you cannot control them, what is the point of a signal that the sender never notices? The answer is that the signal was never for the sender. It was always for the person looking back. The point of an honest signal is that someone else can read it, and the human visual system turns out to be exquisitely, unconsciously tuned to read exactly this one. The story of how we know this begins with an accident in a darkened room in the early 1960s. Eckhard Hess, a psychologist at the University of Chicago, was lying in bed one evening, looking at a book of animal photographs, while his wife observed that the dim light seemed to make his pupils larger. Hess, being the kind of mind that takes a casual remark and turns it into a research program, started wondering whether the content of what a person looked at, not just the brightness, changed pupil size. He built an apparatus to photograph people's eyes while they viewed images, measured the pupils frame by frame, and discovered that the aperture opened for pictures people found interesting or pleasant and stayed small for pictures they found dull or unpleasant, all in constant light. He gave the field its name, pupilometry, the measurement of the pupil as a window into interest and emotion, and he spent years documenting that the eye opens toward what the mind is drawn to. His most famous demonstration involved showing men photographs of a woman's face that had been subtly altered so that, in one version, her pupils were large and in the other they were small. The men could not consciously say what was different between the two pictures. They reported no difference at all, but they consistently rated the woman with the larger pupils as more attractive, more appealing, warmer. Something in them was reading the aperture without their knowledge and letting it color their judgment of another human being. That this was happening below awareness is the entire point, and history had stumbled onto it long before Hess named it. Centuries ago, women in parts of Europe used drops made from the plant Atropa belladonna to enlarge their pupils before social occasions because wide pupils were considered beautiful. The name belladonna itself means beautiful woman in Italian. The plant contains a compound, atropine, that blocks the parasympathetic signal to the sphincter muscle, the constrictor. So with the constrictor paralyzed, the dilator wins by default and the pupil stays wide. Atropine is still used in eye clinics today for exactly this dilating effect. Those women did not know about the sphincter muscle or the parasympathetic system or the locus coeruleus. They knew only that large pupils made a face more captivating, and they were reverse engineering, through pure observation, a signal that their culture could feel but not explain. They were faking the output of a system they had no idea existed because the people looking at them were reading that system involuntarily and rewarding the result. The aperture had been functioning as a social signal for as long as there have been human faces looking into one another, and it took until the 20th century for science to describe the muscle, the nerve, and the chemistry behind a thing people had been responding to forever. Now layer on top of this a phenomenon that closes the loop between two people, because it turns out pupils do not just get read, they get answered. When you look at another person whose pupils are dilated, your own pupils tend to dilate in response, and when you look at constricted pupils, yours tend to follow downward. This is called pupil contagion, and it has been measured by tracking the eyes of people watching close-up images of other faces. The match is automatic and unconscious, a piece of the broader machinery of mimicry by which human beings unconsciously echo one another's expressions, postures, and rhythms when they feel connected. Your nervous system is not only broadcasting its arousal state through the aperture, it is also tuning itself to the aperture of the person across from you, syncing your level of openness to theirs. Two people who trust each other and lock eyes are running a quiet feedback loop, each one's dilated, unguarded pupils registering in the other's visual system, easing the other's threat circuitry a little further, lifting the other's interest a little higher, opening the other's aperture a little wider, which the first person then reads in turn. Nobody is deciding to do this. The loop runs on its own, through structures neither person can reach, and it is part of what the feeling of connection physically is. Watch this play out at the very beginning of a human life, and the function becomes unmistakable. A newborn cannot speak, cannot understand words, cannot survive a single day on its own. What it can do, within hours of birth, is lock onto a human face and hold the gaze, and it preferentially fixes on the eyes. When a mother and her infant gaze at each other, both of their nervous systems are doing the things we have described: oxytocin rising, threat circuitry quiet, arousal lifted by the deep significance of the other's face, pupils opening. The infant reads the mother's wide, soft pupils as safety and welcome. The mother reads the infant's wide pupils the same way, and the wide-eyed openness of a baby is something adults find almost irresistibly compelling, which is not an accident. It is a signal that has been selected to capture adult attention and care. Long before language, the aperture is one of the channels through which the first and most important bond a human ever forms is built and confirmed. The infant trusts before it has any concept of trust, and the eyes are part of how that wordless agreement is reached. The signal works at the dawn of life precisely because it requires no learning, no vocabulary, and no decision. It is built in. Step back and ask why a signal would evolve that the sender cannot fake and cannot even perceive in itself, and the answer reveals something about why we trust at all. Most signals an animal sends can be faked. A smile can be performed. A friendly word can be hollow. Posture can be staged. But a signal becomes trustworthy in proportion to how hard it is to counterfeit, and there is almost nothing you can do about your pupils. The wiring that controls them, as we traced it, runs entirely through involuntary structures: the amygdala, the locus coeruleus, the autonomic branches, none of which take orders from your conscious will. You cannot dilate your pupils because you have decided to seem warm. You cannot constrict them to hide your fear. The belladonna women needed a poison to do it. This is what makes the aperture such a valuable thing for one nervous system to read in another. It is a signal that comes straight from the autonomic state, unfiltered by intention, which means it is one of the few outputs of another person that is very difficult to use to deceive you. When your brain reads someone's pupils, it is reading something they cannot easily stage, and on some deep level your brain knows this, which is why the signal carries such weight in the wordless arithmetic of whether to trust. So return to the moment we started with, the face of someone you trust, the light leaving their skin and entering your eye. Now you know what the black circle is. It is a muscle, two muscles, set by a tug-of-war between the calming parasympathetic system that constricts and the arousing sympathetic system that opens. You know that in the presence of someone safe, the amygdala goes quiet, oxytocin keeps the defenses down, the locus coeruleus lifts not from fear but from genuine interest, and the long looping nerve carries that state to the dilator muscle and pulls the aperture wide. You know the opening is read, instantly and unconsciously, by the person looking back, that it eases their own guard and widens their own pupils in return, and that this loop has been running between human faces since before we had words, from the first gaze between a mother and her child. The dilation is not romantic decoration. It is the visible surface of a nervous system that has decided, beneath all thought, that it is safe to stop protecting itself and lean toward another person. You cannot command it, you cannot fake it, you cannot even see it in yourself. And that is exactly why, when you look at someone and your pupils quietly open, it is one of the most honest things your body will ever say. The next time you feel close to someone and the world seems to soften at the edges, remember that somewhere behind your eyes a blue speck of cells the size of a grain of rice has turned up its quiet signal. A poison once mimicked it. An infant is born knowing how to read it, and the person across from you, without any idea they are doing it, is opening their eyes a little wider to meet yours.